Hello, fellow chemists. In this video, we're going to be talking about exothermic and endothermic reactions. This is labeled as a basic video because there's really no background information that you need to know to understand what I'm going to be talking about. So, exothermic and endothermic. If we just take the two terms apart, exo means to exit or leave or give off, and thermic means heat. So in an exothermic reaction, heat is given off. You can think of when you light a match and it causes fire. That's an example of an exothermic reaction. Endothermic reaction, endo means to enter or to take in, and then again, thermic means heat. So in an endothermic reaction, heat is taken in, so the object that's reacting actually feels cold. Think of a chemical cold pack. So say you like hurt your knee, and then you have that bag that you smack on the middle of it, and then it gets cold. What's actually happening is there's a bubble inside that bag, a chemical round plastic bubble, and when you smack that bag, it breaks that bubble open, releasing a chemical that mixes with a chemical that's on the outside of that bubble, and it undergoes an endothermic reaction that is cold, and that's why the chemical pack actually gets cold. So exothermic and endothermic are typically talking about heat either being given off or heat being taken up in a reaction. But overall, there's really several types of energy that can be given off or taken up in a reaction. And I tend to tell my students, when you're thinking exothermic, endothermic, yes, it's heat, but the other types of energy that can be given off or taken up in a reaction, you want to kind of keep those in mind as well. So the types of energy. And there's three main types of energy that can be taken up and given off in a reaction. One that we already talked about, heat. But then there's also light. An example of a reaction that gives off light is lightning bugs. So in the middle of summer, when you see all those little lightning bugs and their butt starts to glow, that is an exothermic reaction where it's giving off light energy. And then the third type of energy that can be given off in a reaction is sound. And an example of a reaction that gives off a lot of sound energy is actually the sun. If you got close enough to the sun, and assuming that you didn't burn up and die, if you ever heard like a TV screen with the snow on it, the background sound of the snow on the TV screen when there's no channel on it, kind of amplify that by 1,000,000, and that's the sound of the sun. So the sun is pretty interesting because it gives off all three types of energy. The sun gives off quite a bit of heat energy, gives off light energy, and people don't realize it, but the sun also does give off a lot of sound energy as well. So those are three types of energies that can be given off or taken up during reactions. Now, the last thing that we want to talk about in this video are looking at something called an energy diagram with respect to either an endothermic or exothermic reaction. And an energy diagram is just kind of showing you time on the x-axis and energy on the y-axis. And let's say the energy of your reaction starts at this level here. So you'd put an R there. That means that's your reactants. Those are the things that are reacting. And then they tend to require some initial energy that's put in. And then as the reaction goes, it kind of levels off down here. And this would be the energy of your products. And this up here, this point where it kind of like stops having to put energy in and energy starts coming out, that's called the transition state. Now, I drew a reaction here that this would be an example of an exothermic reaction. Because the reaction is giving off energy. You can see the products are lower in energy than the reactants. So this is an energy diagram for an exothermic reaction, where your products are more stable than your reactants. Now, if we wanted to take a look at an endothermic reaction, So endothermic would look, the energy diagram would look a little bit different. So again, you're still going to have your x-axis and your y-axis. Okay, and you'll still have time on your x-axis and energy on your y-axis. And we can say our reactants start at, basically the same amount of energy. They still have to have some transition state energy. But our products then, so this is still our transition state. But now notice how our products are higher in energy than our reactants. So this is our energy different, and our products actually have more energy in them than our reactants. That means energy was required or sucked in during the reaction. Well, this is an example of an energy diagram for an endothermic reaction. So again, you just want to remember, for an endothermic reaction, the products are higher in energy than your reactants. And in an exothermic reaction, for an energy diagram, the products will be lower in energy than your reactants. All right, that's it for this video. I hope you learned something. If you did, make sure to subscribe and like, and I will see you for the next lesson.